Now D1, thus the overtaking operation can be divided as we have discussed earlier, D1, D2 and D3. So D1 is the distance traveled by overtaking vehicle A during the reaction time t second from position A1 to A2 as we have discussed. Then D2 is the distance traveled by the vehicle during the actual overtaking operation, and D3 is the distance traveled by the oncoming vehicle C during the overtaking operation. So here one thing you can notice that the vehicle C, which we will adopt, basically that vehicle C is also coming with the design speed or as the similar speed of the vehicle A. We just adopt this for our calculation purpose. So our OHT is basically D1 plus D2 plus D3. Now from A1 to A2, from A1 to A2, the distance D1, which we have discussed already, D1 traveled by the overtaking vehicle A is reduced with the speed VB meter per second. So why he has reduced? Because he just tried to find out any opportunity, so that the vehicle A will adopt the lower speed of VB meter per second and follow the vehicle B. Okay, and basically that follow up will be happen during the reaction time t seconds. So your distance d1 would be vb into t. Okay, so in this overtaking sight distance consideration, that t as per the IRC, t is 2 seconds. Consider t as 2 seconds, so your d1 would be 2 into vb. Now from a2 to a3, the vehicle A starts accelerating, shift to adjoining lane, and cross or overtake vehicle B, and then coming to its original position. Okay, and they will maintain a spacing S. Okay, that distance, that is called spacing. Okay, now this spacing as IRC is given one empirical formula to estimate the spacing. Okay, so this vehicle will maintain the spacing over here and over here also. So that spacing is given in d1 equal, that is 0.7 vb plus 6 meter. Okay, the spacing s is 0.7 vb plus 6 meter. Now from a2 to a3, the distance d2 is further divided into, so a2 to a3, that distance d2 is further divided into b plus 2s. So s is basically spacing and b is the time taken for the overtaking operation. Now one thing you can notice, if we consider that overtaking time is capital T second, okay, the total overtaking time is T second, in that case you also need to consider that during that capital T second, the vehicle B is cover a distance of B1 to B2, that is the total distance of B meter. Okay, that is also you have to consider. So the total distance which is covered uh, from B1 to B2 would be VB into capital T. Okay, VB into capital T. So another thing, that VBT is we can equate this. How we can equate this with the acceleration, that the distance of vehicle A. So during this t second time, the vehicle A accelerated from the initial velocity VB, and overtaking is completed while reaching final velocity V. Hence the distance traveled is given by d2 equal to, so initially here the speed of the a2 is vb, suppose acceleration is a, in that case the vehicle A will start accelerating, change its lane, okay, then move to its another position, that a3 position, and going with the design speed. So initial speed was vb and the final speed is v meter per second. So your d2 distance, we can also consider this as vbt plus half a t square. Okay, these are the equation of statics. So in the initial case we have found that d2 equal to b plus 2s. Okay, then you know what is the formula for s. So here it would be s basically. So your 2s plus vbt equal to vbt plus half at square, or you get 2s equal to half at square. So from this you get to know what is the value of t. Okay, so you put the value of t in that equation, in this equation. Okay, so your d2 equal to 2s plus vb root over 4s by a. So this is the next portion.